The PEKILO project was started in 1964 at the Finnish Pulp and Paper Research Institute. The first object was to find a microorganism capable of growing submerged in a sulfite spent liquor, easily separable, with a high protein content and good nutritive value. About 300 different species of microfungi were first studied as surface cultures and later as submerged cultures. After these laboratory tests, about 10 fungi species remained, whose acute toxicity was investigated at Helsinki University, employing rats as test animals. Since none of the microfungi proved acutely toxic, feeding tests of several months' duration were carried out at the same institute. The nutritive value of the products was in general as good as that of soya meal and skim milk powder. Already during laboratory cultivation of the microfungi, it was noted that the product, on account of its fibrous structure, was easily separable from the growth solution. A continuous process is a requisite for mass production. For the development of a continuous process, the tests were made on a laboratory scale with a 14-liter fermenter. The tests were successful, and accordingly the fermenter size was first enlarged to 100 liters and later to 1,000 liters. The aim of these tests was to produce an amount of cellular tissue sufficient for large-scale feeding tests, for the planning of a commercial-scale process, and for investigation of the spent liquor from different sulfite pulp mills. The PEKILO process is not confined to acid calcium bisulfite pulping, but can be applied to the ammonium, sodium and magnesium processes as well, when these are performed in such a way that the cooking liquor contains a sufficient quantity of carbohydrates. In addition to the carbohydrate-containing solutions derived from the woodworking industries, agricultural carbohydrate-containing solutions and the byproducts of the sugar industry can be used in the PEKILO process. Besides the spent liquor, inorganic nutrients such as ammonia, phosphoric acid and potassium chloride are required in the PEKILO process. The spent liquor and other nutrients are continuously pumped into the fermenter, where the solution is mixed and aerated at a constant pH and temperature. The protein product formed and the spent liquor used are continuously removed from the fermenter. At this stage, one of the major advantages of the PEKILO process becomes evident. Special separators are not required in the process, since the product is fibrous and can thus be easily filtered. Moreover, only small amounts of wash water are needed, and thus the washing stage does not impose a heavy load on the evaporation plant of the sulfite pulp mill. Rats were employed in the first animal tests. Large amounts of protein products were not required in these studies. Against this, several tons of PEKILO protein were required in tests with pigs, calves, poultry and fish. This protein was manufactured in a continuously operated 1,000-liter fermenter. Because of the structure of the product, the separation, washing and drying could be carried out with entirely provisional equipment. Thus, filtration was effected in an ordinary laundry centrifuge. Some of the production stages were unorthodox. To get the product into a suitable condition before drying it in a heating cupboard, it was processed in a meat grinder. The drying of PEKILO protein is not expensive, since a considerable proportion of the water can be removed by mechanical pressing. PEKILO protein can be manufactured as a powder or, for example, in the form of granules. The granular condition is often favorable, as the substance does not produce dust and is easily handled. PEKILO protein is an excellent component in pig feed. The tests on pigs were carried out at the Agricultural Research Centre of Finland on 96 pigs divided into 4 groups. All pigs were fed with barley and skim milk powder, wholly or partly replaced by PEKILO protein. In all test groups, the average growth was the same. After 3 months, the pigs were slaughtered and examined at the State Veterinary Medical Institute. Nothing unusual was noticed. The tests on calves were also made at the Agricultural Research Centre. The calves were divided into 3 groups, of which the comparison group was fed with skim milk powder. The first test group was given a mixture containing 33% of PEKILO protein in skim milk powder and whey. The second group was fed with 67% PEKILO protein in whey. The whey was used as a lactose source. Growth in the different groups was the same in every way. In addition, tests were carried out with chickens and egg-laying hens. The protein used for comparison consisted of a mixture of soya meal and fish meal. In the test groups, 20, 40 and 60% of the protein was replaced by PEKILO protein. The results indicated that PEKILO protein can be used with good result in the raising of chickens. In the case of hens, egg laying after feeding with 50 or 100% of PEKILO protein was as good as with fish meal alone. Feeding tests were further made with rainbow trout. Commercial fish food was employed for comparison. The growth of the fish was followed regularly during the course of testing. The fish were anesthetized, measured and weighed. With the aid of animal tests, it has been established that PEKILO protein is a good component in feed. The product is tasty, and the test animals were willing to eat it unmixed. Protein is continuously manufactured in the PEKILO process by the application of certain microfungi. Suitable carbohydrate sources are, for example, the spent liquors of the woodworking industry. The protein product can easily be separated, and water can be removed from it mechanically prior to drying. On account of its fibrous structure, it can easily be brought to the desired condition. The product is rich in protein and a good vitamin source. It's been established that it's excellent protein matter for calves, pigs, and poultry.